Bismillahirrahmanirrahim. Topical question paper, part 5, and the topic is current. The course is Cambridge O Level Physics, course code is 5054. Let's start the questions. Question number 1. A lamp designed to work at 1.5 volt is connected to a cell of electromotive force 1.5 volt. The lamp is now connected to 4 similar cells, each of EMF 1.5 volt arranged in parallel. What is the effect of connecting the extra cells in this way? If you connect these cells in parallel combination, then the terminal voltage will remain the same. That is, if the voltage of a single cell is 1.5 volt, then the parallel combination of 4 cells will also generate 1.5 volt. So, but the advantage is that the cells in this parallel combination can deliver current for longer duration of time. So, option C, the lamp produces light for a longer time because it can receive current for longer duration from this battery. Okay, question number 2. The diagram shows a potential divider system of two resistors connected to a 6 volt power supply. What is the reading on the voltmeter? To solve this question, we have to find the voltage across the 10,000 ohm resistor. Two resistors are connected in series and 6 volt is the input voltage. So here voltage divider principle is applicable, and according to this principle, the ratio of the division of the input voltage is 10,000 over 12,000, and this ratio will be multiplied with the input voltage, that is 6 volt, and the voltage across the 10,000 ohm resistor is thus 5 volt. So option D is the correct option. Question number 3. A length of resistance wire is used as a resistor in a simple circuit. 4 separate changes are made to the wire. Which change will not reduce the value of the resistance of the wire? Okay. Option A. It is covered in an insulating sleeve. If the copper wire or the resistance wire is covered in insulating sleeve, then its resistance will not be affected. It will neither reduce nor it will increase. The resistance depends upon the length of the wire as well as the cross-sectional area and the operating temperature. These three parameters on which the resistance of any wire depends on. And insulating sleeve or some kind of insulation won't affect the resistance of any metal wire. So option A. Question number 4. Sets of voltage current readings are obtained for different electrical components. Which set of readings is for a 100 ohm resistor? The correct option is option B. In option B, if you take any data set, then the outcome will be 100 ohm. For example, voltage is plus 1 volt in option B and current in milliampere is plus 10 milliampere. So in this case, the resistance will be V over I. So V in this case is 1 volt and the current is 10 milliampere. 1 milli is 0.001, and when you take this 0.001 to the numerator, it becomes 1000. 1000 divided by 10 is equal to 100 ohm. If you take another data set like plus 3 or 30, still the outcome will be 100 ohm. If you take another data set, for example minus 2 and minus 20, then the outcome is still 100 ohm. So for all the data sets present except 00, The outcome is 100 ohm in option B. Okay. Question number 5. The diagram shows a simple electric circuit. Which row describes the charge on an electron and the direction of electron flow through the resistor? The charge on an electron is negative and the electronic current flows from the negative terminal of the battery to the positive terminal of the battery. So option A. Question number 6. When three identical resistors are connected in series, their combined resistance is 6 ohm. What is their combined resistance when they are connected in parallel? As three resistors are connected in series and their combined resistance is 6 ohm, so the value of the individual resistor is total resistance divided by the number of resistors. This is the formula. Total resistance in series is 6 ohm and the number of resistors are 3. So 6 over 3 is 2 ohm. So 2 ohm is the value of the individual resistor in series combination. Now these 2 ohm resistors are arranged in parallel. So in parallel configuration, the formula is 1 over R is equal to 1 over 2 plus 1 over 2 plus 1 over 2. Okay. So if you solve this, then 1 over R is equal to 3 by 2. So R, if you invert these two values, then R is equal to 2 by 3 ohm. So option B. Question 7. The diagram shows an alarm system in which the switch S is shown closed. What happens when the switch S is opened? Okay, in this configuration, when the switch S is closed, the the current is flowing in the upper circuit and the iron core will be magnetized. So this magnetized iron core will attract the iron, and due to this attraction the lower circuit is cut off. That is, there is no current flowing in the lower circuit. However, when the switch is open, then the magnetization effect of the iron core will come to an end and there is no more force of attraction on the iron. So the iron will drop on the metal, and in this way the current will flow in the lower circuit and the bell will ring. So option A, iron will drop on the metal and the bell will ring. A written explanation is also here, so I can read it for you. When S is closed, current flows through iron core and the iron core it is magnetized. It then attracts iron as long as the current flows through it. When S is open, no current flows through iron core and it is demagnetized. And in this case, the iron drops on metal. When iron drops on metal, the the bell in the lower circuit uh, will ring because the circuit is complete. So again, if switch S is closed, then the current is flowing in the upper circuit. Iron core is magnetized. Iron in the lower circuit is being attracted towards this iron core, and the lower circuit is in off condition. When switch is open, then there is no magnetization effect in iron core, and the iron will drop on the metal, completing the circuit completing the path of the current in the lower circuit. and due to this electronic current flowing in the lower circuit, the bell will ring. So iron will drop on the metal and the bell will ring. Option A. Okay. Question number 8. When a filament lamp is switched on, there is a current in the lamp. As the temperature of the filament rises, its resistance changes. Which pair of graphs shows how the resistance R of the filament and the current I vary with time after the lamp is switched on? Okay, as the lamp becomes hotter, its resistance will increase. And from Ohm's law, we know that there is an indirect relationship between resistance and the current. So if the resistance of the filament is increasing due to its because of its rising temperature, then the current will decrease in the bulb. So it's a kind of inverse relationship. If you see, there are only two inverse relationship you can see. One is in B and the another one is in D. But the resistance of the lamp will increase as the lamp gets hotter. So option B is the correct option. Okay, question number 9. 1 volt can also be written as 1 joule per coulomb. 1 volt can also be written as 1 joule per coulomb. Question number 10. The circuit diagram shows three resistors in parallel with a battery. What is the effective resistance of these three resistors? Okay, these three resistors are connected in parallel. So to finding the effective or the net resistance or the total resistance, the formula is 1 over R is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So here three resistors are connected. So 1 over R is equal to 1 by 4 plus 1 by 2 plus 1 by 1. And 1 over R is equal to 1.75. Now if you inverse these two values, that is 1 over R is equal to 1 by 1.75. If you inverse these two values, so R is equal to 1 over 1.75. And 1 over 1.75 is 0.57 ohm. It's option A.